Well, the next thing we're going to consider is three-dimensional objects with forces, obviously. And here I have a plate that is subjected to these three forces. These three forces are all parallel with the z-axis, in fact. And they will, well, because they're parallel with the z-axis, they won't have any moment caused about the z. However, they may have some moment caused about the x-axis and about the y-axis. So what we want to do here is replace these three forces with one force acting at a position in the xy plane such that the effect or the moments about the x and y axis is going to be the same before and after. So let's draw our before condition. Before condition is going to be equal to the resultant, and that's going to be equal to, because they're all going in the negative j direction, that'll be negative 100, I'm sorry, the negative z direction, negative k, minus 100, minus 500, and minus 400. So those are going to be equal to minus 1000 in the k direction. That's the resultant. The moments about the x-axis before, well, this moment, or this force has no moment about the x-axis. It goes through the x-axis. This force has this lever arm, so that's 4, and this force also has a lever arm of 4. So let's go ahead and write those down. So that'd be 500 times 4 minus 400 times 4. Those are both in the negative axis or negative direction, so that's going to be equal to negative 3600 Newton meters. How about the y-axis? Moment about the y-axis. Again, this force goes through the y-axis, but this one, the 100, has that lever arm, the 500 has that lever arm. So let's go ahead and put those in there. That'll be 100 times 3 plus 500 times 4. And those are both positive, meaning they're both trying to rotate in this direction about the y-axis, and by the right-hand rule, that would make that positive. So that's going to be equal to 2300 Newton meters. So again, this is the before condition. What we're looking for is where should we apply this resultant at a place on the xy plane so that the moments are going to be the same. So what we want to do is redraw this now. I'm going to move this up here and redraw this plate such that it looks like this. Where the x and the y and the z, and I'm going to put that 1000 newtons right there, r is equal to 1000, and I want to find the location in the y-axis, or in the y dimension, and the location in the x dimension, so that the result is going to be the same. That's x and y. Alright, so the after condition, we want the moment about the x to be equal to the same, and that's going to be 1000, which is the resultant. Well, let me just put it more properly and say that this is going to be the resultant times the y dimension. That's going to be equal to 1000 times y. So there it's clear to see that y is equal to 3.6, and that would be meters. Moment about the y-axis is going to be equal to 2300, which is equal to the resultant times x, which is equal to 1000 x, and you can see that x then is equal to 2.3 meters. And those are the two answers that we'd be looking for when it comes to moments about those axes. Okay. What I would like you to do now is pause the video and work this problem out. What we've got is a resultant of these four forces pointing straight down through the origin, down through the z-axis. The forces are unknown, however all the distances are known. So in this case, solve for those two forces so that the moments about the x-axis and moments about the y-axis are going to be the same before and after. So I'll pause the video and let you work on that. Well, here's the solution for that. What we want is the moments before to be equal to the moments after. But since the resultant goes through O, the moments before and after are both equal to 0. So in that case, it's no moment before, no moment after. Everything has to be equal to 0. So let's look at the moments about the x-axis. I've got 6 times this lever arm of 650, and FB times this lever arm of 750, and those are both going in that direction, which would be positive x. Positive rotation about the x-axis. Here on this side I have FA, which is unknown, times 600, and 8,000 times this lever arm. Those are both going in the negative x-axis. And then the result has to be equal to 0. So I have one unknown here, and it is a function. Well, I have two unknowns, FB and FA, and they're kind of functions of each other. So now let's sum the moments about the y-axis. I have in the positive y direction, I have 6 and FA, and they both have lever arms. Well, actually, I beg your pardon. The 6 has a lever arm of 100 millimeters, and FA has a lever arm of 150 millimeters. Those are both going in the positive y. In the negative y, I have 800 times that lever arm, and FB times that lever arm. Those are both going in the negative y. So I sum that up. And again, the result has to be equal to 0 because, let me put the resultant in here right straight down there so we're tracking with that. And then doing the arithmetic, I get FA is equal to a function of FB. So now I have two equations and two unknowns, and all we have to do is equate those and simplify that, and I can get FB is equal to 16.67 and FA is equal to 18. I didn't actually solve for the resultant. It wasn't really asked for, but if you need to solve for the resultant for some reason, then add those to the original forces and you can find out the total resultant.